Welcome back to the Fusion 360 tutorials. In this video, I am going to explain constraints within Fusion 360. Sketching is probably the most important part when you are doing 3D modeling. With sketching, you need to understand constraints, and constraint is dimensioning or constraining a profile or a sketch so that it cannot be adjusted or modified. So if any other future changes are made, that the features or attributes that you want to stay permanent, they stay permanent. So the constraints are very, very important. And I'm going to go through each of these before we get into actually sketching profiles. On the screen here, you'll see some items in here, some sketched items that I have prepared, and I'm going to go through and explain each one of these sketched constraints. The constraints are available up here in the tab, Constraints tab, and each one of these items has a description, and most of them are actually pretty logical. So for instance, this one here is horizontal or vertical, so they have a horizontal or vertical lines. This one is coincidence, which is a point on a line or a curve. A tangent, equal sign, parallel, looks like two lines that are parallel. Perpendicular, shows perpendicular lines. This is a fix, which we're not going to use too much. A midpoint, a concentric, collinear, which is two lines in line with each other, and symmetry or symmetrical. And curvature, we're not going to use that one very much, so we'll stick to the basic ones that we're going to use. So the first one we're going to go through is concentric. So concentric means a circle that has a circle or an arc that has the exact same center point. So look at as the inside of a donut, the inside hole as opposed to the outside diameter. They have the same center. So if we want these two circles to have the same center, we're going to go select the concentric. And if we select the concentric constraint, then select the two objects, it will move those objects concentric to each other. Likewise with these two. And we can move these objects around, and that constraint that we've applied does stay. So we can make lots of changes, but no matter what changes we make, that constraint that we applied stays. And that goes for all the other constraints. The next constraint will be parallel. So we're going to go to the parallel constraint, and what that's going to do is make these two lines parallel, as well as these two lines. And just like before, we can move these lines around. I cannot change the angle, but it will always keep these parallel. The next constraint is perpendicular, so we're going to go up to the perpendicular constraint, select our two lines, and those two lines are now at 90 degrees, and I will do one more, and those are 90 degrees. So they can cross, they can go anywhere, but they will stay perpendicular. You cannot change that constraint unless you actually delete the constraint. The next constraint is going to be tangent. So that is going to make a line that is tangent to a circle. So we're going to select the tangent constraint, and tangent, line, circle, tangent, line, circle. And we can move these lines around, but they will, or the circle around, but they will always stay tangent. The same thing with all the other constraints. So it doesn't even have to be touching, but that line would be tangent to that circle at some point. Next constraint would be equal, and what that is going to do is it's going to make these lines equal lengths. So it does not matter if we want to change this line length, it's going to change the other length. So they are always going to stay equal. We can make circles equal as well. That would make this circle radius or diameter the same, and we can adjust that, and those will stay the same. It doesn't matter where we put them. That constraint is going to stay. The next constraint is horizontal. So if I select horizontal, it is going to make this line horizontal. Now it has an option to go vertical or horizontal. What it's going to do is it's going to choose the closest one. So if this was closer to vertical, say this line here, if I drew this line here, it's actually closer to vertical than horizontal. So if I select the horizontal vertical, it's going to select vertical because it is closer to that. And we can also line up holes so that they are in line with each other horizontally or vertically. So if I select the horizontal constraint, select that center and that center, it does line them up. Likewise with these ones. And I could move these up and I could make them all. I could constrain all of them together. This one's constrained horizontal to this one, and this one is constrained to this one, so I could constrain them both together. So I could constrain this one horizontal to this one, and now they're all horizontal, in line horizontally. The vertical, again, it's just going to be the same as the horizontal. It's if this edge is lines closer to vertical, it's going to make that vertical. So select the vertical constraint, it makes that vertical. And because this hole is closer to, the centers are closer to vertical than horizontal, it will make these vertical as well too. So it all depends. You have to be careful when you're making these, when you're going to apply these constraints, that they are closer to the horizontal or vertical that you like. Now collinear, which is this constraint up here, what it does is put these lines so they are always in line, something that's always in line with each other. So this and that puts them in line. It is kind of similar to a parallel constraint, but I cannot move these out of line. I can't put this line beside this one. They are always going to be in line. So it's kind of similar to parallel. So that is a collinear. And we can make all our lines collinear if we want. And these lines will always stay collinear. Coincident, the next constraint, is going to put a line, a point to a point, or a point on a line. So if we select the coincident, I can select that point and I can put it on that curve. So that point will always be on that curve. It does not matter. I could change that around, rotate that around, but that line, the end of that line, that point is always going to be on that curve. And we can also do a point, end point of a line to another end point of a line as well too. So using a coincident, I can put this point on that curve as well too. Whoops, wrong one. Select that point and that curve. And if I wanted to, I could put this point onto that point. And once again, those are always going to stay no matter what we do with those shapes. So that is a coincident constraint. And the last one is going to be the symmetrical. So what symmetrical is very similar to a mirror command. What it's going to do is it's going to make two objects equal distance apart from a center line or maybe an object line or a construction line. So I have a center line here and I have two objects on each side. What it's going to do, it's going to make them symmetrical, a mirror image on the distance. So if I select the symmetry, we have to pay attention to the order. So we're always picking our two objects first and then our line of symmetry. If I drag this across, I can move that left or right, up or down, and that distance is always going to stay the same. We can also do this with circles, selecting two circles and our line of symmetry there, and it is always going to be an equal distance. So very similar to a mirror. So that explains all the constraints that we are going to need. Once again, these are very, very important when we get to sketching. We always want to make sure our sketches are going to be controlled and fully constrained.